Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, I am going to show you how to complete the square. Basically, I'm going to show you how to take a quadratic equation in standard form and convert it to vertex form. Now, this is a very common practice that is used to solve quadratic equations, as well as to graph quadratics using vertex form, basically identifying the vertex or as well as the transformations to graph the quadratic. So I'm going to work through a whole bunch of different types of examples. Mainly, though, we're going to stick to some fairly basic equations. You can see my c does not change from +1 to -1, and my middle term is going to be anywhere from 2 to 12, but we will deal with different coefficients for my x squared term. We will factor out a 2 as well as have that to be 1. And I also wanted to teach this video, or at least go through these examples in two different ways. One, the kind of more formal approach, just by kind of using the formula to understand completing the square. That's going to be helpful in case you have to deal with a problem that's a little bit more complicated than what I'm doing on this worksheet. For instance, maybe one that's going to deal with some fractions or, some other numbers that we don't cover. And then I also want to cover maybe a way that's a little bit more efficient once you get this practice. And I really feel that after you've worked through 28 examples, you should feel pretty comfortable with completing the square. So let's go ahead and get started and kind of work on the idea of completing the square, how it comes about and how it's going to help us rewrite these equations. So quick little review again. Each and every one of these problems is in what we call standard form, ax squared plus bx plus c. Now, a lot of times you'll hear me talk about the quadratic, the linear, or the constant term. And what I'm talking about is x squared, that's going to be our quadratic term, and a represents a real number. Bx is our linear term, and b represents a real number. And then c is going to be our constant. Now, this is our standard form of a quadratic, all right? And this is something very common. We're very familiar with seeing this form. However, sometimes when we are trying to solve or graph, it's going to be easier to rewrite this in vertex form. So the idea of completing the square is basically taking an equation from standard form and rewriting it in vertex form, which is y equals a times x minus h squared plus k. Now, I understand the numbers kind of changed, and you could use, different numbers for h and k. Just remember h and k represents the vertex of the quadratic, which was very helpful for us that using those when we wanted to graph. But I don't want to get into graphing and solving. I just want to focus on completing the square. And you can see the main difference between these two equations is this has an x squared, and this has a binomial squared, right? It's x minus h squared. So the idea of completing the square is going to be creating that binomial squared. Now, I'm really kind of fascinated as far as understanding why that comes about. But before I get into that, I think it's just helpful just to kind of do the formal approach, doing the formula, just so you can kind of always fall back on this process, all right? And so the formal approach is really just going to be identifying the parts of the problem that you have. Like in this case, a is 1, b is -2, and c is equal to -1, all right? So when you have a quadratic, and this works for any quadratic you're dealing with, any quadratic that you're dealing with is you can identify the a, b, and c. All right, and if you don't, have a or a b, then it's going to be 1, and obviously if you didn't have a c, it'd be 0. Now the next thing is to create this binomial square. To complete the square, all we're simply going to do is take our b divided by 2 and square it. So in this case, b is -2. So -2 divided by 2 squared. -2 divided by 2 is -1. -1 squared is 1. And what we're going to do is we're going to take that value and we're going to add it to our x squared minus 2x. So our quadratic and our linear term. So you can just group your quadratic and your linear term. You have to make sure that that your a is equal to 1 in this case to be able to do that. Otherwise, I'll do a problem in the formal definition over here first. But basically, you're going to take that value and you're going to add it into the first two terms. So therefore, in this case, I have now x squared minus 2x, and then plus 1, and then minus 1. But it's really important for us to remember that when you when you add a 1 inside, you just can't randomly add a number to to an equation, right? The equation is equal on the left side as well as equal to the right side. So if you're going to add a 1, you also have to make sure you subtract a 1. So I still have this 1 from here, but then since I added 1 inside the parentheses, I have to make sure I subtract it again. And therefore, we have y equals. Now, this is another part where students make, have confusion. They're like, how do you write this binomial squared? Well, the nice thing to remember about completing the square is when you complete the square, you always produce what we call a perfect square trinomial, a trinomial that can be factored down to a binomial squared, right? This x minus h squared. And so therefore, I'll just factor this one long ways because I'm not going to do this for the rest of the problems. But you can see x minus 1 times x minus 1 is x squared minus 2x plus 1. So therefore, this gets factored to x minus 1 quantity squared minus 2. And therefore, now you have a quadratic in vertex form, and we have just completed the square. The problem is people forget the b divided by 2. They forgot to add and subtract. They don't understand why we're adding inside the parentheses, and then they forget how to factor. So there's so many ways that I've seen students, kind of make mistakes. So I'm going to also try in a different way to help you with completing the square. But again, that method is something that I fall back on all the time, especially when I'm dealing with some problems that maybe are a little bit more difficult to complete the square with. But the second idea I want to bring up to you is, again, this idea of these perfect square trinomials. Like, for instance, if I have y equals x squared minus 2x plus 1. Okay? Now, this was factorable, right, into y equals x minus 1 quantity squared. So what's maybe another perfect square trinomial that we could understand? Well, what about y equals, x squared minus 4x? Now, in this case, it's going to be 4x plus, you could say, 4. Because this can be factored down into x minus 2 times x minus 2, right? Which is y equals x minus 2 quantity squared. So my goal is, what I want students to see is we want to create these perfect square trinomials. Another perfect square trinomial is y equals x squared minus 6x plus 9. And that can be factored into x minus 3 quantity squared. Another one is y equals x squared minus 4x plus 16. Or let's just keep it as negative. Y equals x minus 4 quantity squared. Okay, so the important thing is if you can identify these perfect square trinomials, I'm going to do one more just because I know I have it in this problem, 5x plus 25. And that can be factored down into x minus 5 quantity squared. So a lot of times when I'm teaching completing the square, I want to show students like these are perfect square trinomials. Now again, if I made this a positive 6, then I would make this a positive 3, okay? So it works both with the positive and the negatives, but just to kind of keep things simple, I'm just going to keep everything in terms of the negative. Now, the reason why I'm bringing this up is because if I see this problem and I want to create a perfect square trinomial, I can see that I have the x squared plus 6x, right? I almost have this perfect square trinomial. So to create a perfect square trinomial, I can remember the b divided by 2, think about it. But hopefully you can just remember x squared plus 6x, I'm going to go back to change my clue. I know this value needs to be added to a 9, right? I have to add a 9 here. That's going to create a perfect square trinomial. And then, but again, you just can't add a 9 out of nowhere. You have to also subtract a 9. And then don't forget there was originally a 1 there as well, right? So you just can't totally forget about the 1. But you can add and subtract a 9. And now we can just group this x squared plus 6x plus 9. And now we know we have a perfect square trinomial. So in this case, we'd have a x plus 3, right? Because this one was a negative, so it was x minus 3, quantity squared, and then negative 9 plus 8 is a negative. Negative 9 plus 1 is a negative 8. All right? And hopefully you just kind of see, boom. In this case, it would have been the same way if we would have done the b divided by 2. 6 divided by 2 is 3. 3 squared is 9. So you can see where that kind of comes from. Now, let's go back to this kind of formal approach here and understand what about when there's an a when a is equal to 1. So what we need to do in this case is we need to first factor out that 2. So what we'll do is we'll have go back to y. So I'm going to have a y equals, I'm going to factor out the 2. And then I'm going to leave that with a x squared minus a 6x plus 1. Okay, now I'm going to complete the square here. All right, so I have this negative 6x. Now hopefully you recognize, negative 6x plus 9, right? All I need to do is add and subtract a 9. So I'm going to do y equals, I'm going to keep that blue here because there's a reason for this. Keep that red. So I like the color code, even though it takes me a little bit longer, and I do apologize for those of you that are like, I get this, I don't need the color code, but I just want to kind of go with this. So that's going to be a plus 9, and then we're going to subtract 9. But again, here's the key part. When you added a 9, you didn't actually add a 9 to this equation. You added a 9 that's being multiplied by 2. So in this case, what we need to do is we need to multiply this equation by 2 as well. Let's use the other blue. Right? This 9 by distributive property is being multiplied by 2. So now I need to multiply this one by 2. And then don't forget here, we still have this red 1. Right? Don't forget that. That's still there. All right, so now we created our perfect square trinomial. So we know that's going to be factored down to x minus 3 quantity squared. This becomes a negative 18 plus 1, which is a negative 17. And there you go, guys. That is the slow way to go ahead and, or the more formal approach to go ahead and complete the square. So hopefully now I've kind of covered both ways. Now what I'm going to do is work through these 28 examples in a little bit quicker fashion. So therefore you can kind of get up to speed on how I'd expect my students to, kind of work through these. All right, so the first one, again, we can factor out the 2. So I have an x squared plus 2x minus 1. And again, this one I'm going to, now I know I'm going to need to add a 1. But again, make sure that you understand you're adding a 1, but that 1 is really being multiplied by 2. So when you subtract 1, that's going to be multiplied by 2. And then we still have this minus 1 over here as well. So therefore, I have y equals 2. I recognize this to be a quadratic, and since the middle term is positive, it's going to be an x plus 1 quantity squared. This becomes a negative 2 minus 1 is a negative 3. All right, let's go and do another one, factoring out the 2. So factor out the 2, that gives me an x squared plus a 4x minus 1. In this case, let's do the 2 divided by 2 squared, right? Or you could recognize this. So 4 divided by 2 is 2, 2 squared is 4. So I have y equals 2 times x squared plus 4x plus 4. And then again, remember to minus 4, but times 2 minus 1, right? So whenever you add and subtract, just remember you factored that 2 out, you got to multiply that back through. So again, this is factored down to an x plus 2 quantity squared. Negative 4 times 2 is a negative 8, minus 1 is negative 9. So in this one, let's go ahead and create our perfect square trinomial here. And hopefully you recognize this. Actually, what am I doing? That's not an 8. I made all those wrong. That's 6. That's supposed to be an 8. No, I want to use blue. I just recognized those. I was like, oh, I did the wrong colors. That's supposed to be an, no, jeez. Oh, come on, where are you? That's an 8, and that was supposed to be a 10. So I had my numbers mixed up. Because it's the whatever this term times 2. Negative 3 times 2 is negative 6. Negative 4 times 2, negative 8. Negative 5 times 2 is negative 10. All right, so now let's go and get back to it. So in this case, my perfect square trinomial is going to be a plus 25. So I'll have a x squared minus 10x plus 25 minus 25 plus 1. And then that can be factored down into an x minus 5 quantity squared and then minus 24. All right, let's go and bring this one down here. So I have y equals, now again, you see this x squared minus 6x plus 1, right? So I can just rewrite this as x squared minus 6x. Let's see, plus 9. Oh, let's do it this way. You're going to add 9, subtract 9, and then plus 1. And then we just know we need to group these two because that produces our binomial squared, or our perfect square trinomial, which can be factored down to a binomial squared. And then this one over here, we can do, again, if you want to do the b divided by 2 squared here, like let's do that. Switch it up. So b divided by 2 is 4 divided by 2 squared, which is 4. So you do y equals x squared plus 4x plus 4 minus 4 plus 1. Okay, so it's either you recognize them as a perfect square trinomial, which is typically, I think with practice, it gets easier. It does become a little bit more difficult though once you start dealing with 3s and 5s and 1, numbers that are not divisible by 2. So therefore you're going to be dealing with fractions. That's why that b divided by 2 sometimes is helpful when doing those types of problems. But besides that, again, even if you get practice, you're going to get much better at identifying those binomial squareds and how to factor them. All right, so let's just kind of keep on going here. Here I can factor out a 2. Therefore, that's going to leave me with an x squared minus 2x. All right, minus 1. And then I recognize this to be my factored form here. Y equals to be 2 times x squared minus 2x. Let's see, that's going to be a plus 1. Plus 1, and then just don't forget the minus 1, but then still multiply that by 2, and then subtract 1. So y equals a 2 times x minus 1 quantity squared minus 3. Here, let's see, we can factor minus 4x plus 4, right? That's going to be my quantity squared, minus 4 plus 1. Right? And again, I looked at this. I say, all right, this is what I had in my head. I saw the x squared minus 4x, and I said, what do I need to add to that to give me a perfect square trinomial? It's 4. Right? And then I just group those together, and now I can factor that down into x minus 2 quantity squared minus 3. This next one is going to be, let's see, we're going to have to factor out a 2. So x squared plus 2x, and then plus 1. All right, and now I recognize, oh, that's x squared plus 2x plus 1, right? So y equals 2 times x squared plus 2x plus 1, but then minus 1 times 2 plus 1. So therefore, y equals, let's say an x plus 1 quantity squared, negative 2 plus 1 is a negative 1. Now moving to the next example, you see, oh, this is actually something special here. This is x squared plus 2x plus 1. I can write this as a binomial squared. X plus 1 quantity squared. So if you have a perfect square trinomial, you don't need to complete the square to create to put it into vertex form. You can just factor it. So again, like that goes back to that idea of understanding perfect square trinomials create binomial squared when they are factored, right? All right, so I was waiting for that one. So now let's just keep on going through it. I mean, again, like we're just knocking these problems out, and you can see that hopefully the work that you're going to see is going to be getting kind of less and less, or at least you're going to understand like what is going to be coming next. So x squared minus 2x plus 1, minus 1 times 2 plus 1, and hopefully, I'm not making any mistakes because you're just kind of doing the same thing over and over again. In this case, I could say that's going to be 5, so it's going to be 25. So I can just rewrite this as a x squared plus 10x plus 25. Right? That creates a perfect square trinomial. So I'm just adding basically a 25 and subtracting a 25. 25 plus 1. And therefore now I can group those together and I get y equals x squared plus, I'm sorry. That factored down is a x plus 5 quantity squared minus 24. All right. In this one, let's go and factor out the 2 first. So we factor out the 2, x squared minus 4x. Plus 1, so therefore you can see y equals 2 times x squared minus 4x. Let's see, minus 4x, that's going to be a plus 4, right? Yep. And then we need a minus 4 times 2 plus 1. So y equals 2. This gets factored down to an x minus 2 quantity squared. Negative 8 plus 1 is a negative 7. Hopefully see here, x squared plus 6x, that needs to be plus 9 minus 9, right? If you add 9, that creates a perfect square trinomial. So I'm already starting to see like I can just add it to the original equation. 6x plus 9. But again, you just can't randomly plus 9. You have to subtract 9, subtract 1. Then I just group these two terms. Y equals x plus 3 quantity squared minus 10. All right, guys, we're almost getting there. In this one, you can see, oh, what two numbers multiply to give me negative, or give me a positive 1, add to give me negative 2? Again, this is a perfect square trinomial. Right? Look. Again, you recognize this. You do so many of these, you start saying, oh, that's a perfect square trinomial. So in this case, I can just write this as x minus 1 quantity squared. And I want you to be able to get, that's the point of doing so many of the examples, is once we start getting into higher numbers or different numbers, you can recognize that relationship. This one's going to be, let's see, that's going to be a plus 4. And then we're going to need to subtract a 4, right? So we have y equals x squared plus 4x plus 4 minus 4 minus 1. And again, the reason why we're adding and subtracting, because adding 4 changes the equation, so we have to make sure we subtract the 4. However, to create our perfect square trinomial, we really only need the positive 4. So therefore, we just do negative 4 minus 1, which is a negative 5. Over here, we're going to factor out the 2 first so we can understand our quadratic. And therefore, we have x squared plus 6x minus 1. Therefore, we recognize this is going to be plus 9. So we could say y equals 2 times x squared plus 6x plus 9 minus 9. But don't forget, it's being multiplied by 2 minus 1. So now let's see, that's going to be a x, oops, don't forget the 2. So that's going to be 2 times an x plus 3. Quantity squared, negative 18, that's a negative 19. This one's really the exact same thing here. Now again, let's see here. Can we make this maybe a little bit easier? You're still going to be adding 9, right? And you're still going to be subtracting 9. I think this one's going to be the exact same equation. It's going to be 2, right? I know that this is going to produce, when I factor out the 2, I'm going to have the x squared minus 6x. So therefore, that's just going to produce the exact same, but it's going to be x minus 3, quantity squared. And then I'm still going to have to subtract a 9 times 2, and then minus 1. So I am thinking this is still going to be minus 19. But let's just go ahead and do it just to kind of make sure. So when I factor out a 2, I get x squared minus 6x minus 1. And then what I'll do is, let's say that's going to create a plus 9. So we have y equals 2 times x squared minus 6x. B divided by 2 squared. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9, right? Or subtract 9 minus 1. Oops, don't forget, that's being multiplied by 2. And y equals 2 times x minus 3, quantity squared, 18 minus 19. There you go. Yeah, so I was good. Okay, so you can start kind of making, hopefully you can see, I start recognizing some of these patterns. I can work them out a little bit quicker. So let's maybe try to see if we can make some good estimations here without maybe showing all of our work. Because we have already done 20 problems. And I think just by doing these 20 problems, I think you guys can kind of see that, yeah, we're starting to get a little bit better at this. So here's going to be my perfect square trinomial. I recognize this to be, that's going to be a x plus 1, quantity squared. And therefore, if I added a 1, then I'd have to subtract 1. So therefore, that'd be a minus 2. Over here, that's going to be a y equals x plus 5, quantity squared. And therefore, if I added a 25 to create that perfect square trinomial, I'd have to subtract a 25, so that'd be a minus 26. Here, it's really going to be the exact same thing. It's just I'm going to change the binomial. So y equals x minus 5, quantity squared, minus 26. Over here, I'm going to want to factor out the 2 first before I look at this. So this would be x plus 4, x squared, sorry, plus 4x. Okay, so therefore, let's see here. That's going to be a x plus 2 quantity squared. So that'd be an x plus 2 quantity squared. And then if I added a 2, I'm going to have to subtract a 2. Multiply that by 2, that's going to be a negative 4. Plus 1 is a negative 3. And again, guys, I'm doing a lot of this work in my head for speed. But obviously, you could always check back to all the problems that I showed all of my work to go ahead and do. And I think you would see where my answers are coming from. So y equals 2 times x squared plus 6x plus 1. So therefore, this is going to give me the quantity squared, y equals 2 times x plus 3, right? Quantity squared. So if, therefore, I had to add a 9. That means I'm going to subtract a 9. So it would have been a negative 9 times 2, which is a negative 18, plus 1 would give me a negative 17. In this case, that is going to produce here y equals a x minus 3. Quantity squared, and therefore to obtain that I would have to add a 9, so therefore I'm going to be subtracting a 9 on the outside of that trinomial, and then minus 1 is minus 10. And again, let me just kind of do this one more time in case you're not following me. So I have y equals, x squared minus 6x. I had to negative 6 divided by 2 is negative 3, negative 3 squared is 9. So I created a 9, subtracted a 9, minus 1. So this minus 9 is what I was doing in my head, which I was figuring out. And therefore, that's how I was giving me the answer. And again, I could probably think about this in my way. When I factor out a 2, I get an x squared minus 4x minus 1. That's going to be a x minus 2 quantity squared, so therefore I'm going to be adding a 4 to create this perfect square trinomial. So let's see, that's going to be y equals 2 times x minus 2. So you're going to add a 4. That means outside of the parentheses, I'm going to be subtracting a 4. That has to be multiplied by 2, so that's going to be a negative 4 minus 1 is a negative 5. All right, last but not least, guys, let's go ahead and here we have y equals, let's see, we're going to have to add a 4 to produce a perfect square trinomial, and therefore minus 4 to keep the equation the same. And again, let's just look at this one last time. We had an x squared minus 4x. If you add a 4 to that, you create a perfect square trinomial. To keep the equation true, you have to subtract the 4. And therefore, then we have x squared minus 4x plus 4x minus 4. What am I doing? I'm like losing it. Last problem. Okay. Plus 4x plus 4 minus 4 minus 1. Now we can group together those first trinomial, which is a perfect square trinomial, which is going to be an x minus 2 quantity squared minus 5. And there you go, ladies and gentlemen. We have now just completed 28 examples for completing the square. I know I just did a lot of the same problems over and over again. But again, I chose these problems on purpose because I feel that if we are going to do too much variety, it's not going to be really drilled into your brain as far as the process that you're going to want to follow. So I hope that this has helped, and I hope that now you have a little bit more confidence when you have to complete the square on your own, as well as for some different types of numbers. So thank you again for joining, and I look forward to seeing you on the next video. Cheers.